Hey everybody, in this video we're going to learn about translations. So a few vocabulary words that we need to talk about today, one including the image. And the image is the new position of a figure after a transformation. So if you have, let's pretend we have a triangle A, B, C. Okay? So then the new position after a transformation, let's pretend that we slid the triangle that way and we created, that's terrible, let's go with A prime, B prime, C prime. And all we did was we slid the triangle from the left to the right. So this newly formed triangle after the transformation is called the image. Now the pre-image is the position of an original figure prior to the transformation. So we have the image right here, and then we have the pre-image, so like the original figure. Now the transformation, that when we just slid or translated the triangle from the left to the right, is an isometry. And what that means is that we have a transformation in which the pre-image and its image are congruent. So we just took the triangle ABC and we moved it to the right to create A prime, B prime, C prime. So the fact that we have the pre-image, the image, and the size and shape of the triangle did not change, this is called an isometry. In example 1, we have to translate a figure in the coordinate plane. It says graph and label the quadrilateral ABCD with vertices A, where it's negative 2, 6, B is 2, 4, C is 2, 1, and D is negative 2, 3. We have to find the image of each vertex after the translation. Now this is the rule that is associated with the translation. So it's telling us that the coordinates of x and y are being translated where the x, we're adding 3 to it, and the y, we're subtracting 3. So visually, let's take a look at what that looks like. So let's first graph our points A, B, C, D. There's A, there's B, there's C, and there's D. So we're going to connect all vertices to create our quadrilateral, and now we're going to use the rule that's given to us in the proper notation for a translation. So the x plus 3 means that we are moving to the right 3 units. Every x coordinate of each vertex is going to move to the right 3 units. And then the y minus 3, after we shift to the right 3, we are going to shift down 3 units. So all the y coordinates are going to be reduced by 3. So mathematically, our A prime will be negative 2 plus 3, which is our x coordinate, our current x coordinate, plus 3 according to the rule. And then our y coordinate would be 6 minus 3, which would turn into 1, 3 for A prime. B prime, same rule applies for all of the coordinates. We have 2 plus 3, and then 4 minus 3, where B prime is going to be 5, 1. C prime, we have 2 plus 3, and then 1 minus 3, and that coordinate for C prime will be 5, negative 2. And then D prime, we have negative 2 plus 3, 3 minus 3, and then that coordinate simplified would be 1, 0. So then when we graph that on our coordinate plane, this is our image. This is our pre-image. So our vertex for A prime would be at 1, 3. Our vertex for B prime would be at 5, 1. Our vertex for C prime would be at 5, negative 2. And then D prime would be at 1, 0. So if we connect all of our vertices, we've noticed that our A, our pre-image, moved over to the right 1, 2, 3, and down 1, 2, 3. All of the vertices of the original figure or the pre-image should move the same amount. So we all added 3 to the x coordinate and and subtracted 3 from the y coordinate to get our coordinates of our image after the translation. In example 2, we have to write the translation rule with proper notation and verify its congruence. So it says write a rule for the translation of triangle ABC to triangle A prime B prime C prime. Then verify that that transformation is an isometry. So looking at the directions right away, we have to understand what we're reading. So triangle ABC is our preimage. Triangle A prime B prime C prime is our image, and an isometry is talking about after transformation, is size and shape preserved, or is the preimage congruent to the image? So it's really kind of difficult to look at with the diagram, but if you see at both triangles, we have we have A, B, and C. So then really it looks kind of blurry, but we have A prime, B prime, and C prime. So then this is our preimage, this is our image. So to determine the rule, we have to first write in proper notation. So we know that the x and y coordinate are being affected. So we're going to check. From A, we're going to A prime. So we are to the right of A prime. So with the x coordinate, we are moving to the left 1, 2, 3. So then we should be subtracting 3 from every single x coordinate of the preimage. And we're moving up 1, 2. So then every y coordinate we should be adding 2 to every vertex for the y coordinate of the preimage. So if I'm looking at C going to C prime, we are moving it to the left 1, 2, 3, which matches with A to A prime. And then C to C prime, we're going up 1, 2. That works out as well. Checking B to B prime, we're going to go to the left 1, 2, 3, and up 2. So it looks like we are always moving to the left 3 units and up 2 units. So to write our rule, we take our x and y coordinates with our parentheses around it, and the arrow lets us know that we are translating those coordinates. And we have to determine how our x and y coordinates are being affected. So we just established that each x coordinate is being shifted to the left 3 units, or subtracting 3. So we take our x coordinate and we're subtracting 3. Okay? So then our y coordinates, we talked about how every single vertex is moving up 2 units, and we check that with each vertex. So then our y rule would be y plus 2. This is how you need to write down your transformations or your translation rules. Okay, we have the xy with parentheses and the arrowhead telling us that we're translating those coordinates, and then parentheses, x, whatever the rule is, comma, y, whatever you're adding or subtracting to it, close off the parentheses.